Hello, everybody. We are live again. This is the Chegg online office hour, and today we'll be focusing on Trig and Precalc like always. We will be back next Monday as well. We will be doing this until the end of May. And today I want to focus on exponential equations. So this is like the algebra part of the Precalculus. So when you guys are rolling in, make sure you guys try the first question right here. We have square root of 2 raised to the power of x plus 4, and that's equal to 1 over 8. So this is kind of like a warm-up. Drop your answer in the comment and let me know what it is. In the meantime, I'm going to see who is here already. For the people who are here, thank you guys so much for coming and joining us for today. If you have been here before, welcome back. If you haven't been here before, then welcome for the very first time. Hello, everybody. Hi, Kenneth. How are you? Sina, how are you? Today, we'll be focusing on exponential equations. So this is the first equation that we'll be working on. But for now, I'm just waiting for people to come in. So another minute or two. And in the meantime, if you're here already, try to solve this right here. The answer is infinity. No. Been doing so many limits. I see. Hello, everybody. Thank you guys so much for coming. All right. All right. A lot of people coming already. All right. So here's the deal. All right. This is the online office hour brought to you by Chegg. If you want to see more office hours like this for your other classes, such as chemistry, computer science, go ahead and check out the QR code. Just scan it and maybe check out the link in the description so that you can see the schedule for the week. We will be back on Mondays, including next Monday, of course, from 6:45 p.m. to 7:45 p.m. All right, so you guys should have enough time for the people who are here already. Let's solve this. As I said, just like a warm-up. So whenever you want to solve exponential equations, here are some strategies that I want to go over today. But if you have any questions, make sure you leave your question in the chat as well. I can see your chat, right? Strategy number 1, you want to make both sides have the same base. So right here we have 2, but we have the square root. It's okay. We can actually turn the square root into a power form, which is the 1/2 power. So let's write this as 2 raised to the 1/2 power and then raised to the x plus 4 power. And that's equal to, we have 1 over 8. Well, if you kind of do this a little bit, 1 over 8, it's the same as 8 to the negative 1 power. And in fact, for the 8, is what? 2 times 2 times 2. 2 to the third power, right? So we can look at this as 2 to the third power and then raised to the negative 1. So right here we can say that's 2 to the third power and then raised to the negative 1. And as you can see, we are making a very good progress because now when we have a power to another power, we can multiply these two exponents. This is 2 and then 1/2 times x plus 4. And that's equal to 2 for the base here. And then we do 3 times negative 1. As we can see, we have the same base right here. Here is the technical part. Whenever we have the same base in an exponential situation like this, then the powers, this must be equal to that. And the reason for that is because exponential functions are one-to-one, meaning if the outputs are the same, that means the input have to be the same as well. So this right here, we can just conclude that 1/2 of x plus 4 has to be equal to 3 times negative 1. And then we can just solve this equation. The usual way, distribute 1/2 like this, because I see that we don't like fractions. You could do it like this, no big deal. But I will keep it like this. 3 times negative 1 just negative 3. I will choose to multiply both sides by 2. Slightly easier, so that we can cancel them. And then you can see that is x plus 4. And that's equal to negative 6. And then finally, just minus 4 to both sides. And then everybody be happy. X is equal to negative 10. Here, I'm going to use my eraser. Negative 10. And that is the answer for this equation. It might look intimidating at first because of the square root and also the x in the exponent. But if you know the fundamental, this is not so bad. So strategy number 1 is that make sure we have the same base so that we can just equate the exponents, and then usually you can just go from there pretty nicely. Okay, so today we'll be focusing on exponential equations because last time I showed you guys polynomial equations, right? And these right here are just the algebra part of precalculus. Remember, for precalculus, as I mentioned it before, there are two main parts. One is the trig, right? And we did trig many times in the first few office hours already. Right now, I just want to focus on some of the algebra part. Last time, we went over the polynomial equations, synthetic division, and also long division, all that. Today, I want to focus on exponential equations. All right, cool, everybody. Hello, everybody. For the people who are here, welcome back. If you have been here before, right now I'm reading the chat. If you have been here before, just typing me. Thank you so much, though. All right, just typing me in the chat so that I know you have been here before, and I really, really appreciate that. And I also really appreciate Chegg for giving me this opportunity to host the online office hours with you guys. In the meantime, I'm going to erase the board, and then I will see who has been here before. Also, if you have any questions, try to keep it with the same topic for today, which is exponential equations or any like algebra or logarithm, things like that. Feel free to drop it in the chat. I'll be happy to answer them for you. All right, let's see who have been here before. All right. Oh, wow, so many people. Thank you guys so much. Let me see if I can find any questions that you guys have from the chat as well. All right, so there's a carbon dating question. Wow, let me see, so many messages. So carbon-14 half-life is 5,730 years. And all right, I don't have a calculator. Well, I do have a calculator. I can just use a computer later. But let's try it. All right, let's try it. So this is about carbon. This is carbon dating. Carbon dating. And we know carbon, so I will just write this down. We know that half-life is 5730 years. And then today you just find like a little carbon and you have like, so fossils, let me just write this down. Fossils, wait, so many fossils found with 28% left. 28% of carbon left. So how old, right? How old is the fossil? So thank you so much for the question. And let me see. We can also try solving cosh x equals 3 using exponential. That's similar to what we will be doing later. So I will kind of save that later. And then also there's a quadratic exponential. That's actually what we'll be doing later on as well. I see the e to the 2x minus 3 e to the x plus 2 is equal to 0. We'll do that later. No worries. And all right. So depends on which form of the formula that you use. Usually I use this one. A is equal to A0 e to the kt. A is the amount that you get after t years. A0 is the initial amount. E is the special number E, of course. K is the rate, which we don't know at the moment. T is the number of years, right? So firstly, we are going to use this right here to help us to find out the rate. So half-life is 5,730 years, means that originally it's like 1. Just imagine 100%. And after 5,730 years, so T will be 5,730 years. We will only get half of it left, which is 0.5 or 1/2, up to you, right? And then we can solve this exponential equation. So for the k first. So we are going to see, well, the 1 doesn't matter, so I'm just going to write it like this. E to the 5730k equals 0.5. To get rid of the e, we are going to take the natural log, because this is the same as saying log base e. Natural log and e, they cancel each other out. Do the same thing to the right hand side. And then you will get 5730k equals ln of 0.5. Divide this to both sides. Our rate k is equal to ln of 0.5 over 5730. So this tells you how fast the carbon is decaying. And I'm just going to plug this back into the k, and that will help us to solve this question. So I'm going to just erase this. My board doesn't work today, see? It's not working, so I really have to erase. I'm very sorry to disappoint you. A0 is original, so we can put it, let's just keep it, e to the kt. I want to keep this right here. Okay, so A0 is like 100%, so 1. E is e, k is this. I'm just going to write it as ln of 0.5 over 5730. And the t, we don't know. It's like after so many years, originally we have 100%, but right now there's only 28% left. We are going to put 0.28 here. And then I'll go just to solve for t, and I'll do it. So same thing, we end out with an exponential equation because t is in the exponent. I'm just going to write it e to the ln of 5 over 5730 t equals 0.28. Once again, we take the natural log to both sides. Cancel. ln of 0.5 over 5730 t equals ln of 0.28. And then we multiply the reciprocal to both sides. So 5730 over ln of 0.5. And then 5730 over ln of 0.5. So that cancel. And then we just have to enter this onto the calculator. And maybe you guys can help me out with this real quick. In the meantime, I'm going to read your chat, right? So please go ahead. That will be blocking. Please help me out. Enter this onto a calculator or onto like a online software and let me know what you have. Is it 10,540? I see one answer so far. Let me get some confirmation. Is it 10,540? Let me see. He's doing it the hard way. Well, this is more like a standard way. It depends if you are doing this for the first time or not, and this is the usual way that we go about it. Of course, you can see that there's a shortcut because the numbers, this is just the half-life. And you can always do this. It's just ln of the percent that you have divided by ln of 0.5 multiplied by the half-life. It's always like that. Thank you guys so much. Thank you, George. Thank you, friends. And I also see others. Fushia, I think. I'm sorry if I pronounced your name incorrectly. I'm very sorry. But thank you so much for the answer. This is T approximately 10,000 523 something years. And that'll do it. Right? All right, let's do the next one. The how should I say? It's like a quadratic exponential equation. So let's do the next one. In fact, that's one of the questions I prepared for you guys as well. Very similar. So just do that. So this right here, we have to use natural log, right? Because we have e for the base. Now, for the second one, let's do this. E to the 2x minus 3e to the x plus 2 is equal to 0. Why did I say this is like a quadratic exponential? It's because notice that this is e to the x and this is e to the 2x. Let me change this a little bit. This actually depends on how you want to look at it. Let me change this. This right here is the same as saying e to the x and then square. Because we can just multiply the exponents and we get the 2x. So we are looking at it like this. And then continue minus 3, wrong color. Minus 3, and then e to the x is just e to the x, and then plus 2. So this right here is actually a quadratic equation, but in terms of e to the x. And we can actually nicely factor it. If we factor it, we just get e to the x as the input. Right, e to the x times e to the x gives us e to the x squared. To get positive 2, it's just negative 1 times negative 2, so that they can also combine to negative 3. So minus 1, minus 2. Now, put the first factor equal to 0, and then put the second factor equal to 0. For the first one, e to the x is equal to 1. Well, you can take the natural log again, but here it's equal to 1. Sorry, this is equal to 1. Take a natural log on both sides. X is equal to 0. Let me write it here because I think that's blocking. X is equal to 0. I'm just going to write it right here, so that you guys can see x equal to 0. This is the first answer. Okay, thank you. Next one, put the 2 to the other side. E to the x is equal to 2, and then take the natural log on both sides. So cancel e to the x equals ln 2. Second answer. No, what am I doing? It's just x. Just like that. Pretty cool, in my opinion. I love this kind of exponential equation inside of a quadratic equation. 2 to the x is equal to I. I think that's a little bit out of the scope of this live stream because for usual Precalculus or Trig, like we don't really do that kind of equations. And I think I see the other one earlier. Okay, let's do this one from Francisco, 40 raised to the x minus 1. I think I need to have more space, so let me erase this. Okay, so here we have 40. Let me write 40 raised to the x minus 1, and this is equal to 2 to the 2x plus 1. Am I right? Let me double check. All right, so this is from Francisco. Let's see. This is also like a exponential equation that I have prepared for you guys. So let's do this. The problem with this one is that 40 and 2, you can't really break down 2 anymore. For 40, if you break it down, that's the same as 2 times 20, and then 2 times 10, and then 2 times 5. So it's 2 to the third power times 5. If it was an 8, it would have been easier, but it's 40, so you have a factor of 5 in the base as well. So you can't really make the base equal to 2 in a nice manner unless you use logarithm, right? Unless you use logarithm. You can do it like this. Let me show you, because maybe you guys haven't done like exponential equation by looking at this. So let's try it. So for the 40, you really want to have the same base as the 2. So we are going to call out the 2. Just put the 2 right here. And then we are going to write this as raised to the power of log base 2. We can do that whenever the base of the exponential and the base of the logarithm are the same. We can cancel them out. And we have to still get 40, right? And the 40 will be the input. So we are rewriting the 40 as this, right? So note that whenever you have some base b raised to some log power, but if this is also its base b of whatever you have inside, let's say x, this right here is equal to x. Assuming b is good and x is also a good number. For example, if b is 1, it's kind of like n. If b is -5, it's like n because you'll be getting to the complex world. Assuming b and x are nice numbers, then this will be true. So we can do like this. We can do like this. Oh, thank you. Thank you. And then continue. Let's do this raised to the x minus 1, and that's equal to 2 to the 2x plus 1. So we can still make this the same base as that, but you really have to use logarithm. You really have to use logarithm. All right, let me just read the comments a little bit before we continue. Your video have helped me so much throughout my college STEM course. I'm just watching this for fun. Thank you, and I thank you for coming here today too. Thank you so much. Did you take algebraic geometry or algebraic number theory? I took a number theory course, but it was just a basic introduction. So yeah, and that was over like 17 years something ago. Yeah, it's a long time ago. So anyways, though, well, let's continue. Now they have the same base. We can do what we did earlier. So multiply the powers. This right here is 2, and then we do log base 2 of 40, and then times this is x minus 1, and that's equal to 2 raised to the 2x plus 1. Now, the exponents have to be the same per our discussion earlier. So log base 2 of 40, and this is the multiplication. This is not inside of the log. Keep that in mind, because the way that we write it sometimes it might be mistaken. And then for this, we can distribute or we can divide, up to you. Let's distribute. And let's distribute. And then I'm going to write down one more line. This is log base 2 of 40 times x, and then minus log base 2 of 40. And that's equal to 2x plus 1. Now I'm going to bring this to the other side and bring this to the other side. So we are looking at log base 2 of 40 times x. Again, the x is outside of the logarithm. To make it more clear, I think I'm just going to write the x first. Yeah. And then I'm going to move this to the other side, as I said. So that's minus 2x, and that's equal to 1 plus log base 2 of 40. And technically, if you just have a number inside of a logarithm, you don't necessarily have to use the parentheses. So this is okay. And then let's just factor out the x, because we have the x here and the x here. And then we get log base 2 of 40 minus 2 is equal to this, 1 plus log base 2 of 40. Now we just have to divide this to both sides. So ladies and gentlemen, x is equal to, let's write this down first. So this is 1 plus log base 2 of 40, and then this on the bottom, but let me just line up. This is -2 plus log base 2 of 40. Let me just box this in red to make it stand out more. So that will be the answer. me see. I look much younger. Thank you. Math keeps you young, apparently. Maybe, I don't know. Bro, you have no idea how much you help me. I'm happy to hear that. Thank you. Thank you guys so much for coming here today, though. For the people just logging, this is the Chegg online office hour. Today we are doing Trig and Precalc like what we have been doing on Mondays, 6:45 to 7:45 p.m. And if you guys want to check out other things that we have offer for you, make sure you scan the QR code right now. It's right here. Just go ahead and scan it. You use your phone and then scan it or something, so that you can check out the other schedules for the other live streams throughout the week. All right, so let me erase the board, and then in the meantime, we'll take a look at what else you guys have for me. If you have any questions, any math questions, please feel free to drop it into the chat. I can see it, so I will try my best to answer them for you. Oh, there was one question that log cosh x is equal to 3. Let's do that too. So cosh of x is equal to 3. The first thing is, of course, we have to know what the cosh is, right? So by definition, you can turn this into the exponential definition. This right here is the same as e to the x plus e to the negative x, and then divided by 2. And that's equal to 3. So this is the same as that. Yeah, surprise, surprise, right? Yeah, today we're focusing on exponential equations. So at first, this looks like a hyperbolic trig function, but don't worry too much. You can turn that into an exponential function. And of course, I can also tell you that this is the same as saying x is just equal to the inverse cosh of 3. Of course, we can do that, but let's see. By the way, though, cosh of x it's not 1-to-1. So when you take the inverse, you will have to be careful a little bit. So let's do it like this. We are going to find out both solutions. So let's multiply 2 to both sides, and then we will have e to the x plus e to the negative x is equal to 6. But this is like 1 over e to the x. Let's multiply this equation by e to the x. This times this is e to the 2x. Let's write it as e to the x squared. This times this is plus 1. This times this is 6e to the x. On the right-hand side of the equation, let's move to the other side, and that will become minus 6e to the x. And that's equal to 0. So, unlike the equation that we had earlier, which was nicely factorable, this right here, it's not. But it's okay, because we can use the powerful technique called the quadratic formula. And I'm just going to, let's write it down right here. Make sure that we pay slightly more attention to the ABC values. So A is equal to 1, B is equal to negative 6, and C is equal to 1. And then let's just use the quadratic formula. So this right here will give us the input is e to the x. So we will have to say e to the x, and that's equal to the following. Negative b, which is negative 6, and then plus or minus square root of b squared, put parentheses, and then put a negative 6 inside, and then square that. Yes, I just kicked that. But anyways, 4 and a and c, a is 1, c is 1. All over 2 times a, which is 1, like this. Now, this right here is just e to the x. Here we have positive 6, plus or minus, take the square root. That's 36, minus 4, so that's 32, over 2. And then we can break down square root of 32. It's like 16 times 2. So this is the same as saying 6 plus or minus 4 square root of 2 over 2. And then, by the way though, if we take the positive, the result is positive. When we take the minus, the result is still positive because square root of 36 is less than square root of 30. Square root of 32 is less than square root of 36, which is less than 6. 6 minus this is positive. Yeah. Anyways, we can reduce this real quick, factor out the 2. And then square root of 2. And then cancel this. So we get e to the x is equal to 3 plus or minus 2 square root of 2. Yeah. But then at the end, just take the natural log like what we have been doing. Cancel. X is equal to, because we have two answers, I'm actually going to write it down twice just to make it super clear for you guys. The first one is 3 plus 2 square root of 2. The other one is ln of 3 minus 2 square root of 2. So two answers right here. Just like that. Do you guys prefer me box the answer in red or black? Let me know, because I feel like if I box in red, it's kind of cool too. But so far, I've been boxing my answer in black, right? Anyways, just something to ask you guys. Hold on one sec. Cosh x is greater than 1. What was that? Let me see, what was that common for? Oh, 2 square root, you have the 2? Oh, maybe you can simplify this a little bit more by multiplying the conjugate, but I think this is okay too, right? Ah, we could also have complete the square. Sure thing, definitely. Hey, box in red. Okay, cool. It makes it more stand out. At least I'll do this for you guys in this live stream. Later in my videos, I don't know. I will see. It depends on the situation. Right. So for you guys, I will be boxing the answers in red for this live stream, and later on for future live streams as well. We will be back next Monday, 6:45 to 7:45. Still be talking about trig and precalc. So if you have any questions, especially if you're taking trig or precalc right now, make sure you come by next week and then have your question ready. I will try my best to answer as many questions as possible for you guys. Let me see. Do you have thoughts of doing physics office hours? I don't know too much physics, so I don't think I should. I don't think I will be able to, provide value. Unfortunately, I'm sorry. I can do math. This string is when you want to solve an exponential equation, most likely you will have to use logarithm, right? So it's kind of like both. So if you would like to ask me for like a logarithmic equation, feel free to do so as well. Oh, 3 plus 2 square root of 2, yes, it's a perfect square. Not the conjugate, you're right, it's a perfect square with the square root of 2, yes. No, so that question was actually pretty nice because you can actually simplify into a very nice answer. I see. Okay, is it possible to get a function of the prime numbers? You can't, but there's one that's pretty close. I'm just going to write it down. N squared plus n plus 41, which is a pretty famous quadratic, because if you plug in n is equal to 0, n is equal to 2, all the way up to 40, at 40 is not prime, but I think from 0 to 39, you all end up with prime numbers, which is pretty cool. Okay, so let me take a look. Okay, let me see. So you have a question. Why is cosine and sine so special in trig? Because that's like the base of all the trig functions, I will say. So just real quick to answer like a trig question. Why are sine and cosine so special in trig? In fact, once you have these two, you can define the rest with these two in a very nice way. Tangent is sine x over cosine x, and then cosecant x is 1 over sine x. Secant x is 1 over cosine x. Cotangent x is equal to cosine x over sine x. In fact, you don't even have to have cosine, because by the Pythagorean identity, you could have written cosine as plus or minus square root of 1 minus sine square x. And then you could have used this to replace into here, here, here. Yeah. So in fact, sine x is just enough. Derivative of log. We are not doing derivative here, unfortunately, because it's meant to be for trig and precalc. So that's out of the scope of this live stream. One question, can you present a simple problem related to trigonometry identities? You can let me know which identity you want me to help you with. However, for today, though, I do want to keep the focus with exponential equations or logarithms because they are related. Yes, there's a fun fact. Sinh x plus cosh x is equal to e to the x. Now have a look right here. If you guys add hyperbolic sine of x with hyperbolic cosine of x, you get a very nice result. It's just equal to e to the x. Because this right here is e to the x minus e to the negative x over 2. And this is e to the x plus e to the negative x over 2. Now, you have a minus e to the negative x here and a plus e to the x, e to the negative x right here. When you combine them, of course, they cancel. And then they have the same denominator too already. Add this and that is 2e to the x. So the answer is just e to the x. Very nice. After you cancel the 2. Fun fact, yes. Is this real life? Yes. Yeah, we are live streaming right now. Yes, Jason. Yes. So if you have any questions regarding trig or precalc, but today I would like to keep our focus in exponential equations. So if you have any questions, let me know. Let me know that. Oh, thanks for that. We can also say this right here is the odd part of e to the x, and this right here is the even part of e to the x. Yeah. So for more things like that, maybe later on in another live stream. Yeah. Okay, let's see. You have a system of log base 3 of that this is a little bit hard for me to read the math syntax. Log base 3 of p and then squared. Let me see if I can write this down. Log base 3 of p and then squared, and then or log base p squared, like this. Oh, I see. So, but what's the input though? You say log base 3 of p and then square. I assume that's equal to log base of p squared, but what's the input? Yeah, and then the other part. Yeah, I'm sorry, I can't really understand the syntax. And it's a system equation. The other one is log base 3 of p plus q. Okay. And then log base 3 of p plus log base 3 of q. Oh, okay. So that I can. How about this right here? Maybe I'm mistaken that. Let me see. Log base 3. Hold on. Sorry, whenever like there are new messages, like your message will get pushed down so that I'll lose the message. I have to focus on this. Let me see. Jason, to answer your question real quick, yes, whenever you have sine square whatever plus cosine square of whatever, that will always be equal to 1, as long as the insides are the same. So for your question, yes, it's just like that. Okay. 2. Can you cover hyperbolic trig? I did that like a few live streams ago, so maybe later on I can do it again and maybe more questions. Okay. Oh. So it's like this. It's like this, and then with p, and then squared like this. Yes, like this. But why is there a q? If you can solve for p here, then okay, you solve for p here, and then you just plug into here, and then you can find q, right? Yeah, I hope it's something like this. So not so bad, I would say, because for the first equation, you can solve for p, and after that, you can solve for q. I think this is the equation, so I'm going to write it down again. You guys can let me know if it's correct or not. Log base 3 of p squared, this is equal to log base 3 of p squared, like this. That's the first equation. And then the second equation is to have the q here and q here. But let's not worry about that later. Let's not worry about that now. Let's worry about that later. We can solve this first. Right here, we can put a square to the front. And do we know if p is positive or not? Well, actually, we have to, because from here, based on how this is written, p has to be positive, right? So I'm just going to bring the 2 to the front. I don't need to put the absolute value around the p. So this is log base 3 of p squared equals 2 log base 3 of p. Now, we cannot divide this to both sides. I wanted to, but I can't because p could be equal to 1. So technically, I will have to move this to the other side. So this is log 3p squared minus 2 log base 3p is equal to 0. And then factor out the log base 3 of p. And then we will have log base 3 of p minus 2. And that's equal to 0. And then setting this equal to 0, we can get p is equal to 1. Setting this equal to 0, we can see p is equal to 9. Because log base 3p is equal to 2, and then we just do 3 to this power, 3 to that power, so p is equal to 3 squared. So either p is equal to 1 or p is equal to 9. And once we have this, oh man, like they use q for the second equation, that is, okay. If, like, yeah, just plug into, you're plugging p equal to 1 into here and work that out, and then you're plugging 9 into here and then work that out. I think that's it. So I think that will do it. And you can try that. So let me know what it is. And p and q cannot be 0 because otherwise, if the input is 0, log of anything that's 0, it's not defined. But I'm just going to leave it like that because I think the rest will be pretty straightforward. So yeah. And then let's see. All right, I'm looking for any exponential equations or logarithmic equation because when we are talking about exponential equations, we will also have to be talking about log equations. So log and precal. Okay, let's see. Friends, we have a colony of bacteria originally contains 600 bacteria. It doubles in size every 30 minutes. How many hours will it take for you to get 6,000? Okay. So I'm just going to write down the questions on the board so that everybody can see the question that I'm doing. So originally we have 600 bacteria. And then it doubles every 30 minutes. Doubles every 30 minutes. And then how long does it take to get 6,000? Let me see, 6,000. 6,000. How many hours? How many hours to get 6,000 bacteria? Yeah. Okay. So for the 30 minutes, let's just change that to 0.5. Small thing, because how many hours? How many hours? So it's kind of like the half-life example, and it really depends on how you like to do it. You have two ways. I'm going to kind of write it down for you. Either you can start off by the equation I used earlier. A equals the initial amount, A0, times e to the kt. This is the most general form. Or, because it says doubles, you can also do the following. You can also say A or equals the initial amount. But if it's double, you can use that for the base, which is 2. But be careful though. Because you know it doubles every 30 minutes, the general form is this, raised to the little t over capital T. So this capital T is, because we're talking about 30 minutes, it's 0.5 in this case. This capital T represents how long it will take for this to take the action. How long it will take for you to really get double. So in this case, it's just 0.5. In this case here, it's easier if you use the second equation. So let's do that, because I showed you guys the first one earlier. It's the most general way. But anyways though, all we have to do is just say use the equation A is equal to A0 times 2 to the t over 0.5. We want to get 6,000, so that's the target amount that we want. And the initial amount is 600 or 60. Hold on. Is it 60 or 600? 600. Okay. So here we want to have 600. That's the initial. And then just do 2 raised to the t over 0.5. And then solve for the little t. Divide both sides by 600. You can see that it's just 10 right here. So 2 raised to the t over 0.5 is equal to 10. Now, it depends on which log that you prefer to use. You can take natural log, or you can take log base 2. In terms of writing out the answer, log base 2 will look nicer because they cancel right away. So you will have t over 0.5 equals this, and then just multiply 0.5 to both sides. T equals 0.5 times log base 2 of 10. Yeah, and then please help me out with what the answer is. Just use a calculator, enter it. If you enter this as log base 2, you may have to use the change of base formula. Let me just write it down right here. This is the change of base. Which says if you have log base b of x, this is log of this number, which is x, over log of the base. So this is the change of base formula. So in this case, we will have to enter log of 10, and you should have the log key on the calculator, divided by log of 2. right? And then after that, multiply by 0.5. 5 hours? Such a nice number. Let's do 2 decimal approximations. 1.66 hours. Okay, I get 2 answers. 2 people say 1.66 hours. Still pretty nice as well. I'm kind of surprised. I see. Okay, 1.661. This is now 1 and 2/3 because the 0.66 does look like 2/3. I'm going to write it so that it does not look like 2/3. It's 1.661 hours. Much better. Yeah, just like that. All right, let's do a domain question for log. Sure. All right, so you guys want me to do like a log questions more than the exponential question, but that was exponential, so that was quite nice. Maybe next time I can just show you guys the questions I prepared for you guys. Today I want to answer your questions first, so let's do that. All right, another question from the chat. We are going to find the log base 4 of x. So here we have a function log base 4 of x minus. Okay. I don't know if I'm going to write it down to see if this is what you are trying to say for the question. Log base 4 of x. And then I assume the minus is inside because you didn't put any parentheses. And then another 4. And then of 1 over x. So I'm going to assume this is the question that you would like me to do. So let me just wait for the confirmation, and then I will do it. And the goal is to find the domain. So let me get a confirmation from you. If this is the question, then yeah. Because earlier I was thinking maybe you wanted to close the parentheses here. I don't know though. So do you mean this? What do you mean this? So let me know the top one or the bottom one. Let me know. Oh, it's outside, so you mean the second one, right? The second one. Okay. Sorry. Yeah, so it's like this. Much better like this. Seriously. Because when you have a log, instead of a log to find the domain, yeah, it looks very scary. Now, here's the deal. For the domain for log, whenever you have a log function of any base, here the base is 4, so it's good. We don't have to worry about that. But if it's log with whatever you have inside, you have to set out the condition that the inside here has to be greater than 0. So here we see that we have the x inside. So condition 1 is x has to be greater than 0. And then the other one is we have another inside. So go ahead and put 1 minus x also has to be greater than 0. That means x has to be positive. Right here, solve it real quick. We can move the 1 to the other side. And then divide the negative 1 to both sides. So x is, switch the inequality, becomes a less than. So combine this and that together, x is greater than 1, in the meantime it's less than 1, so the domain, I just put on D, is x, it has to be in between of 0 and 1. If you just use the inequality, which that's what I'm going to do, doesn't look like the D, this is the domain. Yeah, there we go. And if you want to use interval notation, that will be 0 to 1. I don't like the interval notation. This is the interval notation. Because it looks like 0, 1 is the point. Yeah. So one way or the other. Yeah, that will do it. If you have the parentheses on the very outside, that actually I don't think that's doable in the sense that because you have log and x, it's really hard to solve that. You have been watching the 100 limits and you are at 6:51:26. Awesome job. Thank you so much. The minus here doesn't really matter. One thing though, do not combine them. You have to go with how the function is written in the first place. So right away, you set up the condition that the first one is greater than 0, and then you set up the second inside here is greater than 0, and then solve for it. Then the equalities individually, so you have the conditions. What if he calculated by hand? I cannot. I don't think. I don't think it's possible. Okay, let me just say a few more things. Oh, you're welcome. Yeah, for this question. Hopefully it helps. And for more help, make sure you guys scan the QR code right here. Right? Just everybody, please go ahead and scan the QR code, especially if you're looking for more help, especially if you're taking math, science, physics, chemistry. Check out what Chegg they have for you. Right? And we will be back next week. We only have 3 minutes left though right now because our live streams go from 6:45 p.m. to 7:45 p.m. Pacific time. So if I cannot answer your question today, I'm sorry. Make sure you just come back next week and I'll try my best to answer everybody's question. So right now, let me just kind of see what I can answer for you guys by just talking because we have like 3 minutes left. Can you bring back the Pokeball? We will see. We will see. You love that. Okay, we'll see. Right. Category theory, I don't know much about it. I don't know. I think I don't know anything about it. So, yeah. Stats is, I think, it's a pretty good one. If you guys need help for stats, and you can also kind of like leave message, send messages to Chegg to see what they can offer for you. Just kind of like request them, and so that way they know what they can do to offer you guys. All right. So that's why I said scan the QR code, and I see people are scanning the QR code right now. Thank you guys so much. I really appreciate that. And then again, I don't have that much time for today. We only have like 2 minutes left. So I'm just reading the questions. I'm just reading the comments. If you have anything that you would like me to know, drop in the chat. Can't believe time passed by so quickly. I know, right? It's been an hour already. Technically, 58 minutes. It's 3:43. Oh my goodness. That's late. 3:43 a.m. That's what country is that? Right now, it's 7. Is that one of the European country? You can let me know. Maybe you guys can drop a comment in the chat and let me know where you guys are from and what time is it. Because right now it's 7:44 p.m. Pacific time. I don't have too much time to solve equations for you. Unfortunately, we have about like a minute. So right now I'm just kind of try to answer many questions as possible. But I cannot solve equations. I cannot solve questions for you guys, unfortunately. Make sure you guys come back next week though and get your questions ready. And again, check out the QR code to see what Chegg they have offered for you. And you guys can also leave a comment in the live stream after we are done so that you guys can let me know what you guys would like to see in the future. We do have to keep the live streams based on Trig and Precalc, right? You guys can leave a comment down below, let me know. The live stream will still be on my channel as well, and as well as Chegg's YouTube channel. Make sure, before we go though, make sure you guys scan the QR code and then check out Chegg's social media, their YouTube channel, Twitch, TikTok, Instagram, and all that good stuff. Right now, the live stream comments, It's not going to be easy for me to read later on. If you leave it in the comment after the live stream is done as a video, it will be better. All right. All right. So this is it for today. It's 7:45. I will see you guys next week, same time,